All right, let's dive in. Today, we're going to break down a really important idea. How do you take coding, which can sometimes feel like just typing commands, and turn it into a true disciplined craft?
So what's the real secret to great code? I mean, what really separates the good from the great? Is it just about being the fastest coder or knowing all the fancy new language features? Well, as we're about to see, the secret isn't just about raw technical talent. It's about having a process, a professional workflow.
You can kind of boil it down to two different approaches, two different mindsets. First, you've got the hacker mindset. You know the type. Move fast, break things, get something, anything working, and just worry about the mess later. And then there's the craftsman mindset. This is all about planning, building with intention, and constantly refining your work. For the rest of this explainer, we're focusing on the craftsman. And here's the thing about craftsmanship. It starts way before you write even one line of code. This first phase is all about the blueprint. Honestly, this is probably where the most important work gets done. It all kicks off with two simple, but vital steps. First, you have to fully, completely understand the problem. What are the real requirements? What are the inputs, the outputs? What are the weird edge cases? If anything is even a little bit fuzzy, you have to ask questions until it's crystal clear. Only then, and only then, can you move on to step two, actually planning the logic and breaking it down into smaller, manageable chunks.
This quote just nails it. A professional doesn't just jump in and start hammering away at the keyboard. No, they deconstruct the problem first. This whole process of breaking it down, maybe sketching out some pseudocode or a quick flowchart, it makes even the most complex problems feel manageable before you've even started the real implementation.
Okay, so you've got your blueprint, now it's time for the build. This next part is all about the principles of writing code that doesn't just work, but is also readable, easy to maintain, and solid for the long haul. So you hear people talk about clean modular code, right? But what does that actually mean? Well, it starts with this core idea, the single responsibility principle. All it means is that every little piece of your code should do one thing, and do that one thing really well. This is what keeps you from creating those giant, tangled monsters of code that are impossible to fix or even understand later on. And that one principle, it's part of a whole toolkit of best practices. You've got things like the solid principles, which are basically rules to make your software easier to change and expand. You've got dependency injection, a fancy term for a technique that keeps your code flexible. And then there's the basics, clear naming, proper error handling, and avoiding those mysterious magic numbers in your code. These aren't just suggestions, they're really the grammar of professional coding. So your code is written, you've run it, it seems to work. We're done, right? High fives all around? Not even close. Now we get to the polishing stage. Testing, refactoring, and optimizing. This is what takes merely functional code and turns it into high-quality professional code. This is the question every true craftsman asks themselves. It's not enough for the code to spit out the right answer one time. Is it reliable? Is it readable? Can someone else on your team, or you, 6 months from now, understand what's going on? Is it efficient? See, working isn't the finish line. It's the starting line. So this means you have to test for everything, not just the happy path where all the inputs are perfect. A craftsman is their own worst critic. They're constantly asking, what if? What happens if I get a null input? What about an empty list of data? What if I throw a massive amount of data at it? These edge cases are exactly where bugs love to hide. This all feeds into what you can think of as the quality loop. It's a cycle. You review your code looking for ways to make it better. Then you refactor it, which doesn't mean changing what it does, but improving how it does it. Make it cleaner, clearer, more efficient. And then, and this is the crucial part, you retest everything to make sure your improvements didn't accidentally break something else. Now, up until now, we've mostly been talking about the individual's process. But let's be real, modern software development is rarely a solo mission. It's a team sport. And that means we need to move from our own personal desk into the shared workshop. And the core process for that collaboration, a lot of the time, is the pull request flow, or PR flow. Think of it like a system of checks and balances. You commit your changes with really clear messages about what you did. You open a pull request to propose those changes. Your teammates review your code, giving feedback, and only after it gets a thumbs up is it merged into the main code base. But remember, a tool like Git is only half the battle. For collaboration to actually work, you need agreed-upon team standards for how you write code. You need automated systems. You'll hear the term CI/CD for continuous integration and deployment to automatically test and release the code. And maybe most important of all, you need clear, respectful communication during those code reviews. So we've talked about planning, building, polishing, and working with a team. What's the one thing that ties all of this together? Well, that brings us to our final and most important section, the mindset of continuous craftsmanship. This quote, this reveals the secret sauce. A true craftsman is never done learning. When they hit a problem they haven't seen before, they don't just hack together a solution and move on. They stop. They research the best practices. They document what they learned. It's a deep-seated belief in continuous growth. And this final quote just brings everything home perfectly. Notice how it's not just a list of random steps. It's a single, connected philosophy. It starts with deep understanding, flows into clean building, then thorough testing and refining, and it's all done inside a collaborative environment. That is the whole picture. So we'll end with this one question for you to really think about. Following a disciplined process like this is what turns coding from just being a job, a series of tasks you check off a list, into a true craft, something you can take real pride in and get better at for your entire career.